Welcome back to your YouTube pre-calculus lessons. This is lesson 4, 2.1, day 2. On lesson 3, we looked at answering questions in the first column. We defined increasing, decreasing, and constant. We talked about when the graph was positive, negative, or equal to 0. Today we're going to focus on end behavior, domain and range, local minimums and maximums, and odd or even functions. If you have any questions from the first column, please make sure you go back and rewatch lesson 3. The first thing we're going to talk about in this video is the end behavior. The end behavior is a way to describe the graph as the x values get very, very large or very, very small. Again, think about as the graph is approaching positive and negative infinity. The first way that we can describe the graph is up on the left and up on the right. That means we're starting up on the left, we're going to do something funky in the middle, and then we're going to end up on the right. It doesn't matter what's happening to the graph in the middle. We only care about what is happening to the graph as we are approaching negative infinity. In the x direction, we see that those y's are approaching positive infinity. As we approach x in the positive infinity direction, those y values are approaching positive infinity. That's positive infinity, positive infinity. That's where we get the up, up. So we can shorten that by just saying up, up. Our second situation is when our behavior is left, down on the left and down on the right. Again, we're going to start down. We're going to do something funky, who knows what, and then we're going to end up coming back down on the right. So now as we look at the graph, as x approaches negative infinity, the y's are approaching negative infinity. As x approaches positive infinity, the y's are approaching negative infinity. And that's how we get our down, down. Now these two functions happen when we have even functions, which we'll talk about. The difference is up, up happens when you have a positive leading coefficient of a, and down, down happens when you have a negative leading coefficient of a. The next one is down on the left and up on the right. So this time we're going to start down on the left. We're going to do something, and then we're going to end up on the right. Again, what happens in the middle is not important. As we look at this function, as x approaches negative infinity, the y is approaching negative infinity. As x approaches positive infinity, the y is approaching positive infinity. Again, when we interpret this graph, we would say down, up. Our last situation is up on the left and down on the right. Again, we're going to start up here, do something, and then end up down on the right. As we look at this graph to analyze it, as x approaches negative infinity, the y is approaching positive infinity. As x approaches positive infinity, the y is approaching negative infinity. That's how we get up, down. Now these situations happen when we have odd functions. If we have a positive leading coefficient, the graph is down, up. If we have a negative coefficient, the function is up, down. The next thing I wanted to talk about is domain and range. The domain and range of a function, as we've defined in Algebra 2, and again this year in pre-calculus, is the x values that work for the particular function, and the range is the y values. For this, now that we have practiced our interval notation, you do want to make sure that your answers are in interval notation. So when we look at this, let's start by looking at the domain. Again, as the domain is our x values, we're going to start with x is an element. We can see that this graph initiates at this point of 0, 0. Therefore, 0 is our smallest x value. And we can see that the graph continues all the way in the positive direction because we have an arrow here, which means our domain is 0 to infinity. Looking at the range is the y values that work for this particular function. Again, paying attention to the fact that this graph initiates here. That's going to be our smallest domain. And now as we're looking for our domain, we can see, or our range, we can see that our largest x value is 10. That point is included, so our range is from 0 to 10. The next thing we want to talk about is the local minimums and maximums. We can also call these turning points, and the turning points relate to the overall power of the function, which we'll describe later on in this chapter. We're looking for the locations where those graphs change direction. Again, we've also called that vertices in the past. So looking at this function, a local maximum is going to be a local high point to the graph. So we can see that we have a vertex here giving us a local maximum. We can write our local maximums in point form. So I can see I have a local maximum at the point, looks like 1, 5, based on our scale of 2 units. I can look again carefully at the graph and see that I have a local minimum down here. Again, that's a turning point, a place where my graph is changing direction. So we have a local minimum at the point -3, -10. Again, it's really important we watch our notation here, that we label those as points with parentheses around them in order to denote what's happening. Now we also have this point up here that looks to be an end point. In most books, that's what they call a global maximum, because that's the highest point on the graph in that end. Notice that the other graph goes, or the other direction is going on to positive infinity. Therefore, our range would be all the way to positive infinity. The next thing we can talk about is odd and even functions. This goes with that idea of looking at the end behavior and kind of connects it all. The definition of an odd function is one that has symmetry at the origin, meaning that a reflection over the x-axis, remember when we reflect across the x-axis, we put a negative in front of our function. That will look the same as a reflection over the y-axis, which gives us a function with a negative inside. If I graph an odd function, one version of that is a cubic function, and this is just a simple cube. If I reflect this graph over the y-axis, it looks like this. If I reflect this graph over the x-axis, it will look the same. That makes that function odd. The end behavior of an odd function is going to be dependent on the sign or your leading coefficient. An even function is one in which the function looks the same as a reflection over the x-axis as the reflection over the y-axis. The simplest version that I can think of is that is a quadratic. If I flip this quadratic over the y-axis, it looks the same as the original. So we have our original function and a reflection over the y-axis looking the same. All right, so now that we've watched this video on the second column of questions, we're going to have an opportunity to practice that with a bookwork assignment. Once you finish that bookwork assignment, you are going to upload it into your Schoology. We are going to come back to class ready to practice together in small groups. Make sure you guys take notes, watch the videos, and are ready to go. If you have any questions on this lesson, make sure you put them in your notebook, and we will come back and answer those questions together as a class. Thank you, and I'll see you again in lesson number 5.